dear all, dear participants, first of all, let me congratulate the participants on behalf of our university, and with loads of thanks from bottom of my heart to our beloved President Sir for giving us such a wonderful opportunity to conduct international lecture series. So this is conducted on behalf of the first year Engineering and Technology Department of Physics. We have initiated an international lecture series. The first series goes like Applied Physics in IoT Sensors and Communication. So this series, lecture series, mainly aims on providing a skillful platform and a multidisciplinary approach to students. Physics, which is known as mother of invention, has a lot of applications in the field of electrical, electronics, even the IoT, sensors, communication, robots, automation, everywhere the basic concept of physics is used. But when we do a course or a UG or a PG in physics, due to our education system, we do not know, even though we know the concept, we do not know exactly where the concept can be used. So we thought this present scenario demands that even a science graduate should know engineering, technology, and the connection between science, engineering, and technology. So keeping in mind, due to what I can say, due to some other this one, I thought I can initiate such a lecture. So at this juncture, I would like to thank our management for giving us the support. I would like to thank Dr. Balasubramaniam, Director IQSC, who gave an idea of such a lecture. And I would like to thank our speaker of the day, Dr. Krishna Kumar Narayanan. Sir, thanks a lot for you for giving us support for the last 2 years. So actually, sir is involved with us for the last 2 years. He has been doing project-based learning for our first-year students alone. Now we have gone a step ahead, and it has been taken to all the engineering and technology students. That is all years until the final year. So you will be. So I thought we can have even opportunity for the science student. So that is the main aim of today's lecture or this lecture series, right? So I request the students to carefully listen to what sir is telling and grab the opportunity, right? Now this lecture series, if you attend and if you complete, you will get a base platform wherein you can pursue your project or internship in some multidisciplinary areas like electronics, electrical, like that, right? So it depends on the interest of the student only. So with this note, I don't want to waste much of time. I will hand over the session to Krishna Kumar Narayanan sir. Once again, a lot of thanks to the management, all the executive officials, those who have supported us in this endeavor. And I welcome all for this international lecture series. Now I request Krishna Kumar sir to take the stage.
Thank you, madam. Thank you for that wonderful introduction. As you rightly pointed out, it's a great opportunity for students to get to know what is happening in the latest field of applied physics, applied to multiple disciplines. But before I do that, I would like to thank Dr. Shubhashri madam, Dr. Balkishan sir, who has now taken a step further in extending to multiple disciplines, and beloved president and the entire college management, institute management, for giving us an opportunity to share this lecture series. So what I thought we'll do is again once welcome all the students who have participated here. We have prepared a few slides here to go as, but I will make it more of an interactive, and I'll also go to some websites to show you some examples of what I'm talking about. So I'll make it a little bit more show and tell type of a seminar. Also, we have this is an 8-hour long course. We have based upon madam's guidance. We have divided them into four sessions. Each session is 2 hours long. So today we will cover first 2 hours of this course, And of course, we will also share the presentation to Madam as well. So let me start sharing and go through the presentation that we have prepared for this lecture series. Can one of you confirm that you're able to see my screen? Maybe Madam can confirm.
Yes, sir, visible. Yes.
Very good. Okay, so this is the online course on applied physics and IoT, sensors and communications. So keep these two words in mind, sensors and communications. We're going to be talking about these two a lot. I think Madam had the visionary to pick these two areas in applied physics. I'll show you in a minute why these two touch every part of what we do in day-to-day life. And in the session 1 today, we will talk about applied sciences in technology. Okay. So I think people will start coming in. I need to start admitting them. So please give me a minute while I do that. Okay. Now, what are the topics? So today we'll be covering the course overview in terms of what the 8 sessions will be and what we'll be covering in this lecture series, and some of the background and motivation. Why did we pick this IoT, sensors and communication? What is the background? What is the motivation for looking at this particular area for physics students? And I believe this also can be applied to many other disciplinary students as well. I think, as Madam rightly pointed out, it is not specific to one particular degree course or discipline. It is really touching a wide variety of students in science and technology. And we'll take a look at applied physics, areas of interest to technology, especially in electrical and electronics. This is where the sensors come into picture. A lot of them will involve some electrical aspect or the electronics aspect of it, some circuitry aspect of it. Communications is we do this day in day out. I mean, everybody has a mobile these days, so communication is intertwined in our day-to-day life. So that is also a very interesting area of applied physics, especially into the technology. Then we'll touch upon two upcoming areas called private 5G networks and 5G and IoT research areas. So private 5G networks, you all know about public networks like Jio and Airtel and so many other public networks, mobile networks that are available today. But more and more companies, factories, campuses, they're all looking at their own mobile network. I mean, they want to have security, privacy, and faster response, and so many other features that are not available in the public network. So I think this is definitely that is becoming very hot in the industry now. So you'll hear this term private networks, and you probably know about 5G. At least a lot of you would know about 3G and 4G networks. The next generation is already here, and the 5G networks are becoming very important as well. And IoT, which is Internet of Things, and the 5G, they go hand in hand. I think I'll cover a little bit towards the end in terms of why these two technologies are interesting to applied physics students, and what kind of research areas that one could look into if you want to look at your future career, whether it is a job or further higher studies in PhD. So these are some of the areas that you could potentially look at for you. Okay, so that's what we'll do: course review, background motivation, some examples of areas in which we will be covering this topic, and then really talk about the private 5G and the IoT areas. Course overview, like I mentioned, there are 8 sessions. First 2 sessions we will cover today. Applied physics enabling technology is what we will be talking about right after this. And Internet of Things, IoT is becoming a buzzword these days. So we'll try to understand what is it, why is it needed, and how is it getting implemented. What are the industries that are getting benefited, and as a scientist, how can you contribute in this upcoming field? So those are the two topics that we will cover today. And then tomorrow we'll touch upon the mobile 5G communication networks, including private networks, how popular they are, and what are the opportunities and challenges for scientists and engineers for this particular area. Then the next 3 sessions we have allocated for sensors, right? I think which is the crux of our lecture series. So we'll talk about what are the typical sensors used in industrial IoT, such as a manufacturing plant, whether it is a car manufacturing plant or a plastic plant or a chemical plant. Any of these manufacturing plants, what type of sensors do they use? Where do we play a role? How is applied physics getting involved in that, in building those sensors? So that's what we'll spend time on the 4th session. Followed by smart cities. Again, this may be something that you may be hearing in the newspapers. Many cities are trying to make their infrastructure, whether it is street lights or traffic signals, many of those infrastructure that they provide to the community. How are they becoming smarter with sensors? And green energy is another buzzword. Everybody is trying to save the planet. So going green, making sure that we use reusable energy. So how does sensors play in that? How do we measure the amount of power that we use? How do we optimize it? How do we get an alert that something is going really over the budget? So a lot of those sensors are applied in the green energy. So those two are for the industrial IoT. For the consumers like you and I, what can we do with the smart homes, right? And these days, more and more electronics gadgets are coming into our home. Gone are the days where we are doing things manually, starting with mixie, grinder, and refrigerator, toasters, you name it. A lot of them are getting more and more intelligent. They're getting to be more and more smarter. So turning on lights, turning off lights, setting up the temperature or the thermostat for your AC. If you have a pool, you can turn off the heater for the pool. So things like that are becoming more and more important for the smart homes. And SME stands for small and medium businesses. Whether you're a dentist or a grocery shop owner, what kind of things that you can do to make sure that your store is protected or serviced better with IoT. So there are some use cases for small and medium businesses as well. So that's all about the sensors. Then we talk about in the 5G communication, especially for voice and speech analysis. You all probably know about Alexa or OK Google, the voice assistant, where you can speak into it. It does it sends the signals to the cloud, gets the information to you, and voice recognition become very important. So what are the type of sensors used in the 5G communication? So about 4 sessions will focus on sensors and how they are used in the industrial as well as in the consumer market. Finally, we'll conclude with some research topics and discussions. It's more of an open forum where, based upon what we have learned about IoT, about sensors and communications in various market segments, what topics can you take as a master's student in physics, either for your additional project or for your further studies or in a job or a company that you may be interested in going to. So that's what we have planned for this course. And some of the background and motivation. I think you would have seen in my title that I started out my career as BSc Applied Sciences. I've always believed that sciences, I think Madam also pointed out, it's fundamental to engineering and technology. Without science, there is no engineering, there's no technology, and especially applied sciences is fairly advanced in helping in doing different things in engineering and science in technology. So this reason why I was fascinated to take BSc Applied Sciences, where physics, math, and chemistry were primarily the focus for that course. So I always believe that that is an essential component of doing engineering and technology. So that's one reason why we decided to do this course. And is becoming as important as electricity. And then we talk about communication. Internet is the way we all communicate. In fact, the seminar that we are currently going through would not have been possible without internet. So clearly, it is as important, if not some places more important than electricity. So things are getting connected to the net. It is a way of life, and the pandemic has accelerated the connectivity. So communications, whether it is voice communication, data communication, messaging, they're all becoming very, very important for our day-to-day life. Automation, right? And we know that not everything can be done manually. Nuclear reactor, managing that, or sending a robot to take care of certain things in the chemical plant. So things like that are becoming more and more important. So this is another reason why sensors are going to play a major role in those areas. I think we already talked about sensors. They're everywhere, whether it is homes, institutions, businesses, or factories. You will find them everywhere. I think some of them you may already know. Some of them we may not even know that there are sensors inside those gadgets that are sensing something, whether it is a temperature or a pressure or air quality, anything. So you will see that you'll see some examples as we go down. Communication and messaging, like I mentioned, is a way of life. Mobile phones and computers are all the tools that we use every day, and just about everybody has a WhatsApp account, and we follow Twitter, we use Messenger. More than talking, a lot more people are spending time on messaging. So communication and messaging is becoming an important area as well. So when we look at all of these things, when we say applied sciences is core to engineering, and sensors are important, communication is important, we said why don't we create the series? So this is a background for our lecture series. So our course is designed as an inspiration for you to uncover how sensors and communications are enabling Internet of Things, and what kind of things in this particular area, what kind of projects that you can do. There are so many do-it-your-own type of projects that are available to you. So things like that we can also uncover as we go into the course. So that's about background and motivation. And somebody drew this picture about role of applied physics. Hundreds of areas, as you can see, whether it is electronics or audio processing, lots of these fields are captured in this one diagram that shows physics is the background for a lot of these things that are happening in electronics and communication, and then that's what we will take a look at in IoT, sensors and networks. So let me briefly show you Wikipedia site where let me see if I can bring that up. I think there are some more people. So I was just looking at when we were preparing for this lecture, what is applied physics? As you can see, there are hundreds of areas, and there's an ever-growing field. You can go to the Wikipedia and take a look at some of the areas like accelerator physics, including AI. It's fascinating to see that AI and scientific computing, they all come under applied physics field right now. So specifically, we'll be taking a very tiny portion of applied physics called electronics and electrical engineering and sensors and communication. But if you go through this particular field, I would strongly urge you to take a look at this particular and then go into some of them, and some of them are very, very interesting, including nuclear engineering, geophysics, you name it, aerospace engineering, tons of areas where applied physics is heavily used. Of course, if you want to do more in the medical field, there is microscopy and nuclear physics and optical physics, the plasma physics. Those are all areas. In fact, there is an area called medical physics where you can get into as well. Radiation become a very important aspect of medical industry now. So as a scientist, there are plenty of opportunities for you to apply whatever you learned in your course, in your master's course, in your projects, into some of these areas. So we will not have the time to go through each one of them, but I thought it'll be a great place to refer to, and so you can take a look at them offline. But in our particular field, we will be squarely focusing on electrical and electronics and communication. Okay, so that's what we plan to do. Go back to my presentation. Okay, so let's talk about each one of them. Like I think Madam briefly talked about how electrical, electronics, and communication engineering derive a lot of the fundamental concepts from physics. So in electrical engineering, monitoring and managing power grids. As you know, power, as I mentioned, though internet and electricity are the same foothold, electricity is still very, very important for us. Nothing runs without electricity these days. So monitoring and managing power grids in any city or state or a country is becoming more and more important, and security requirement also, because a lot of the bad people, they're trying to take a hit at your power grids. So lots of the governments are making plans to make sure that these power grids are monitored for any unknown activity or unwanted activity around them. And not only the security point of view, but also from the functional point of view. How is the transformer, how is the temperature of the transformer, how much is the current that is going through. So a lot of the grid characteristics of the power grid monitoring and managing becomes essential, and sensors play a very important role in each one of them. Whether it's a camera is also a sensor. It can take a picture and recognize who's there, who's not there. It can take a video and try to analyze it, whether it is normal or abnormal. So a lot of sensors in the power grids area. It's a subject by itself. If you go in the internet and look for smart grids, you'll see tons of examples of sensors who are applied there. Smart power meters, for example, at our own homes, from the electricity department. These days, gone are the days where human personnel had to come and take readings from your home. These meters are becoming smarter. They can alert you saying that you're going over the limit or going over the budget. So a lot of those meters are equipped with sensors as well. So purely from the electrical engineering point of view, as you can see, there are plenty of examples of sensors that we see. Electronics engineering, circuits is a very important aspect of electronics engineering, whether it's an analog circuit or a digital circuit. These are basically a circuit board that electronic appliances may have, including our computers and mobile phones and anything that has some display on it. You will see an analog or a digital circuit that is used. So printing circuits and making sure that the circuit boards are properly manufactured. There are sensors who detect the abnormality in circuits. So that's one area where we see sensor getting used. And there are many types of sensors in electronics engineering. For example, temperature sensor. How do we measure the temperature? How do we measure pressure? How do we measure humidity or air quality? So there are sensors available for each one of them. In the future classes or sessions, we'll take a look at specific sensors for each one of them, and then see how they operate, and then how tiny they are. Right, a lot of these times these sensors have to be very, 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 very small in size, and there are very strict requirements for battery consumption. You don't want the sensors to consume a lot of power, because a lot of them need some battery power to run on, and you don't want to go change the battery every day. So we'll talk about what are the requirements of the battery. So when you get into some of these areas, you may be asked to design a sensor with the smallest sensor possible. That's where you apply some of your physics concept that you've studied in the course. And how do you design them for space? How do you design them for efficiency? How do you design them for better materials? How do you make sure that the material that you choose are appropriate for the sensors, and so on. So that's on the electronic side. Communications, antenna theory. I mean, everything that we see, whether it's a radio or a television or a mobile phone, all of them, they have antennas, right? That's how they get the radio signals. So you would have gone through the electromagnetic signals in your physics course. So some physics departments even offer antenna theory as courses as well, because these are kind of stepping stone into, if you want to do your further studies in communications. Antenna theory becomes an important one. How do you design them? How do you implement them? What are the characteristics? There are so many variations of this antenna, right? Whether it goes inside your small phone, or even your little dongle that you get from Geo, they all have antennas. Wi-Fi is an example of an antenna where Wi-Fi sensors are used. So that's another area where you could look into for looking at how to improve those sensors in those areas. So good understanding of radio signals and varying frequencies. I think you would see, what frequency these signals are getting transmitted and received. Right? You have radio stations, you have TV stations, you have mobile networks. They're all in different spectrum of frequencies, and a very good understanding of how these spectrums are used for various communication technologies, and which one do you really care when you want to design an antenna for a phone, what frequency that you should be really focusing on and preparing that. So if some of you are focusing on the frequency spectrum, or the signal processing of electromagnetic signals, then this could be a great area as well. So what I thought was we'll just tabulate some of those examples for these three areas of interest. Then let's briefly touch upon mobile. So just a little bit of a background in terms of mobile technology. We started with 2G, where it was primarily a circuit switch technology. That means whenever you make a call from one mobile to the other, there is a circuit that is assigned. There is a physical line that is assigned, just like in telephones. There's a telephone line that is associated with the call between the two parties. Even in the mobile phone, there is equivalent to a circuit that is assigned between the two parties in the 2G spectrum. So primarily it was a circuit switch technology that was used in 2G, but then that had its own limitations. It becomes very expensive when you have a large, lakhs and lakhs, of not crores of people trying to use a mobile network. The circuit switch technology is not going to provide you the coverage, and also the cost was really a big factor. So slowly, the 2G was moving to the 3G, where the technology was going to more towards packet-based technology. Packet-based is how we communicate over the internet, right? So when we want to transmit information, we just assemble them as packet, called IP packet. We just dump them onto the internet and say this is the address that you need to deliver this packet, and then you don't have to worry about. You just keep sending the packet, and then likewise the packets will keep you'll keep receiving them on the other end. So it's a distributed technology that allowed the mobile networks to have voice over IP. So all the voice calls were going over the data channel, and so that became very important for the mobile networks, whether it is Geo or Airtel or other mobile networking companies. They have been switching from 2G to 3G. I'm sure a lot of you are on the 3G network now, because data is now more important than voice, because more and more people are using apps that require data connection. So mainly the 2G 3G networks are used for voice calls and very rarely for data. So then came 4G, where it was more, the speed was definitely one of the consideration, but this is also the time when we had widespread adoption of packet-based technology. So basically the companies, the mobile operator companies, they're trying to drop the circuit-based technology completely and move everything over to data. So even when you make a call over WhatsApp or Facebook Messenger, any of those calls, Skype calls, they're all packet-based calls. So they were able to accommodate more and more packet-based voice calls. So 4G mobile network allowed them to do that. And data-enabled services, like as I mentioned, mobile apps, m-commerce. I mean, these days mobile is everything for us. Whenever we do anything related to mobile, we use the data plan a lot, and all of that is possible only through 4G. Upcoming is a technology called 5G, but the more interesting thing about 5G is a terminology called fixed wireless access. So what that means is, today, for example, at your home, you may be getting your internet through cable, right? It's a fiber cable or a copper cable coming into your home. that provides you the wireless that provides you the internet connection to your home, and then with that you will connect a router, and then you have your Wi-Fi access at your home for your mobile phone or your laptop. But the wire is expensive, right? The infrastructure to wire a cable to your home is also error prone. Through climatic conditions, the cable can go bad. You would have probably seen, during a storm, your cable may not be working fine, your internet may be down. So there are so many issues with the cable based internet. So what the mobile operators are trying to do, they're trying to bring in mobile wireless fixed, they call it fixed wireless access. So you just get a router that is 5G enabled router. You just use that. It's a wireless router, and that's how you get your internet to your home. You don't need any more wires coming into your home. So the technology is uh, really advanced these days. So you can get the equivalent to the wired broadband connection. In some parts of the world, people are getting 5G speeds that are really, really high. So more bandwidth than 4G. That is certain things. Definitely one of the plus points of 5G. But then mobile broadband combining various wireless technologies, whether you use Wi-Fi or cellular, it combines all of them together. And IoT and 5G are helping each other, mainly because today, for example, humans are connected to the internet, right? I mean, a lot of the we're all connected to the internet, but things, right? Electronic things are not connected yet. But what we anticipate is the billions and billions of these small devices are also going to be connected to the internet. And without a 5G technology, IoT is very difficult to realize. So this is the reason many of the companies who are focusing on IoT, they are also heavily investing on 5G. So we'll cover that in the future section. But at least in the mobile telecommunication sections, these are the key things that one needs to know. How we have come a long way from 2G, 3G, 4G to 5G, and now the IoT, it is taking off, and a great need for sensors. I mean, what is bottom line for us is, in order for IoT to be successful, the ingredients are here. 5G is here. The sensor technology is in great transition period right now, because suddenly there is all kinds of sensors are needed, and then IoT will drive that the sensors market. So that's on the mobile and telecommunication space. 5G private networks on IoT. I think this is a term you can. When good news about student such as yours, you are living in a very exciting era where a lot of the information is available at your fingertips, right? When I was in college, it was you need to go to the library. Some of these journals would not have come from abroad. You need to wait for weeks and months before they are available. There was no internet. Today, you all have mobile. You can go Google 5G private networks. You'll get a ton of information. Use it. I think there's a lot of information out there. But in general, what that means is, I think I briefly talked about the private networks. For example, our college, our educational research, we can have our own private network. So the way it works is, the campus has a private network, and the college issues SIM card, right? I mean, just like how um, mobile carrier, whether it is Jio or Airtel, they issue a SIM card. You go pop in your SIM card in your mobile phone, you get that network. So that's the public network policy. A private network looks very similarly. So college will generate, let's say, 10,000 SIM cards, and then they distribute to each one of the students, and then you pop it in. Then you're in a private network that only all the communication, whether it is a voice call or messaging, when you talk among each other in the campus, the data stays within the campus. It doesn't go out of the campus. It is very secure, right? Because it doesn't go through GA network, it doesn't go through Airtel. Voice and data doesn't leave the network at all. So clearly, for certain very sensitive segment like government and large enterprises, manufacturing, factories. Those things are very important to secure the data, right? Oftentimes, when there are terrorists who are looking at attacking, they go after some of these large establishments. So it's important in some cases to secure them. And so that's one of the primary reasons why companies and other organizations look at the private network. The second one is low latency. What is latency? Latency is basically when you want to send data from point A to point B, how quickly can it go to point B, right? So for real-time application, that the timing is very important. Let's say you are in a factory setup and you have a boiler that is heating up, and you want to shut down that the boiler, or you want to shut down that valve, or you have a water leak and you need to shut off power immediately, right? Or the water immediately. So there are so many of these real-time applications and services where low latency is really a requirement. You just don't have the time for the data to go to a public network like Airtel or Geo for it to come back to you again. The round trip time from the time you say shut off the wall and really the operation happens, the timing is just too long. And so some industries cannot tolerate that such a long latency. So low latency is another requirement, and that is also driving the private LTE network. Cost effective, right? Like I mentioned, once you set up your own private network, you don't need to pay the public network anymore, right? All of your communication messaging are staying within the network. So it may be you may be saving a ton of money in making sure that you don't pay the public network. Of course, it doesn't mean that you cannot talk to anybody outside. You can still roam onto a public network and make your calls to your friends that are not in your campus. All of those things are already taken care. But I thought this will be an interesting thing for you to get an understanding of, when you design a sensor, when you design it for a network, it is very important that you understand where this is going, right? So once you understood the requirements, then as a scientist, when you go design this hardware, then you will keep a lot of these things in consideration. And 5G private networks and IoT, this is the latest trend. I think you will probably hear this terminology, Industry 4.0. Many companies talk about that. So right from the industrial revolution that we have gone through, we are in the fourth phase of that industrial revolution. And so I think you probably hear about Digital India. All of them is part of that initiative, right? Where everything needs to be connected. Broadband is an important thing for everybody, right? It's just not for IT companies only. Everybody needs to have connectivity, and every device needs to have the connectivity, whether directly or indirectly. And so many organizations are investing heavily into this space. So one thing to think about, the 5G private networks and IoT, this is truly a multidisciplinary field, as Madam talked about. Scientists is where the work starts, right? If you don't design the sensor properly for an IoT, none of this thing is going to be possible. You can have the best network, you can have the best software, you can have all best gateways, but if your sensors are defective, then it is useless. So it's very important to have a very good understanding of how the sensor technology works, and how quickly they can sense things and transmit the information to the rest of the network. Is going to be a very important aspect of it. So I think that is what we are planned for the first session. Let me park here in the beginning and see if you have any questions. You can either ask me in by unmuting, or you can put it in the chat, and then I can take a look at that one as well. Let me go to stop presenting. Yeah, let me open it up for any questions, comments, feedback on the first session in terms of why applied physics is critical and essential for engineering and technology, and especially on IoT and sensors. We touched upon two broader areas, sensors and communications. So I hope that gave you a good flavor of importance of physics and applied physics in this marketplace. Any questions, comments? You can also use your chat window if you'd.
Good morning, sir.
Good morning.
Myself Sandhya, final year MSc student.
Sure. Yeah, go ahead.
Sir, I'd like to comment about the series today, sir.
Sure.
It was really nice. You explained us about the applied physics, how it builds a bridge between the physics student and the engineering student. It was also good. We learned so many things about sensors. It was really a new thing and a very interesting one too. Thank you, sir. That was all about.
You're welcome, Sandhya. I think you kind of summarized it also for other students as well. It is a bridge. I think Madam also talked about the world is getting smaller and smaller. About 10, 15 years ago, we were all living in islands, right? The math student was living in the math island, physics was in physics island, and chemical engineering was in the chemical engineering island. But what the internet has done, it has really broken all the barriers and said, no, it's all the same universe. If you don't have physics, if you don't have chemistry, you don't have this, you don't have that. So I think it elevated a lot of everybody's importance. I think that is what the main purpose of the first presentation is, to inspire you and say, don't think that science is behind technology or anything like that. It is, in fact, it is behind every technology. So so yeah, thanks, Sandhya, for that wonderful comment. Thank you for that. Yes, I think Guhan, yeah, you had something in the chat. You have a question or a comment? Please go ahead.
Sir, myself Guhan, I am studying BSc Physics.
Please.
Yes, sir. My question is whether many experts says that after enabling of 5G, it will reduce the traffics.
It will reduce
It
the
may possible, sir.
it will reduce the traffic. What do you mean by that?
Sir, traffic jams by the vehicles. It may
Yes,
align. Yes,
yes,
sir.
yes, you're absolutely right. I think the vehicle to vehicle communication, it's called the V2V. I think
Yes,
that's
sir.
a very interesting one that you brought in. So today we call P2P, people to people communication. When we communicate, like the way we are communicating right now, or let's say you talk to somebody over WhatsApp, it's P2P. It's peer to peer or
Yes, sir.
people to people.
When they are using artificial intelligence to do that, sir.
Exactly. So basically, the vehicle to vehicle communication. So the way the IoT and sensors are taken over the automobile industry. About 30 years ago, the ambassador car was the only car that we had known, right? Or maybe one or two others. But literally, there was no electronics. But now, if you go to a modern car, it is filled with electronics, and a lot of them are sensors based, right? I think the way, as you pointed out, Guhan, the vehicle has a sensor. It can talk to other vehicles around its own field. So basically, the cars can talk to each other, and they understand where they are. They can understand the distance between the two of them. They also know what speed this car is going and what speed the other car is going. So it is really possible to avoid collision. So it can save lives. And a lot of the times you just don't have the time for the car, the sensor, to send the data to the cloud, to understand what the information is and come back. So all of this information has to be locally within the car. So IoT and the 5G network, and there's another technology that we will talk in the I think in the fourth session or so, we'll talk about edge computing. So these technologies are going to enable the vehicle to vehicle communication, and that is going to revolutionize the transportation industry. So yeah, you are absolutely right. Artificial intelligence is going to play a role. It is already playing a role in cars like Tesla, right? The pure electrical
Yes,
vehicle. All of that, the self-driving cars. How do they know, right? They have sensors, they have cameras all over the place. They understand the surroundings, whether it's a 2-lane highway or a 4-lane highway. What is around me? Are there humans around us? Are there animals around us? What speed are we going? A lot of information it is assimilating in a fraction of a second, right? It needs to. Nobody can replace our brain, that is for sure, but it needs to come close to our human brain in terms of reacting to problems around us, and then take action. So self parking cars are available, self-driving cars are available. So they're all happening. So this is why I said you guys are really fortunate to live in this time. Opportunities are endless, really endless. Yeah, you're right, Guhan. I think vehicle-to-vehicle communication, it definitely comes under IoT sensors. It is truly a multidisciplinary field. Yeah, thanks for bringing that up. Very good comment.
Thank you, sir.
Any other questions, comments, observations? I mean, this is what I would like to see in students in learning more, and see where some of them might interest you. That's where it takes you, right? So whether you, let's say, if you're going for your PhD in physics or applied physics, these are the kind of things that you want to look at. What is needed and what is needed in the community, right? Whatever we do, whatever research that we do, if it is applicable to a human community, that's wonderful. You serve the need for that, right? Whether it is a medical field or a manufacturing field or something for the government, all of them are great examples. Any other questions or comments? Okay, so what we will do is we'll take a short break. Maybe we'll take a 5 to 10 minutes break, and then we'll rejoin. We'll take a look at IoTs. I think we talked about Internet of Things. What are they? Why do we need them? And what is in it for us? I think that's what we'll cover in the second session. Okay, so with that, we will sign off, and I think we will leave the meeting as is, and then we'll come back and join in about 10 minutes. Okay, see you all soon.
Thank you, sir.
Hello.